Hi. For the machine learning project, we are doing a project on poker rule induction. The team consists of myself, Shivraj Patil, and Pratik Sunil Rane. The project is done under the guidance of Professor Gustavo Sandoval. Our goal in this project is basically to predict the hand given set of 5 cards in the standard deck of 52. Say in the given image, we have 5 cards, 5, 6, 7, 8. We basically know this is a straight hand. Uh, this is a very easy problem when you want to when you hard code the rules of the game, the poker game, and run the code. But the problem that we are tackling this in this project is what if we don't know the rules of the game? What if we don't know, given the 5 cards, we should find whether it's sequential and tell it's a straight hand or something else. So here we use here we basically are given the problem is like it's given a data set which contains all the combination of cards and what the cards are, what the hand we get given these 5 cards, and using this data set we build a machine learning algorithm which trains on that data set and will be able to predict a hand which when given a new 5 cards which isn't there in the training set, which is a new um, test data set. The motivation for this project is basically the many games have successfully been used in the domains of AI research over the years, and especially when it comes to the game of poker, which has been identified as a beneficial domain for the current AI research. Basically, it's because of the properties it possesses, such as the need to deal with the hidden information and the probabilities that it has. That is what motivated us to go ahead and um, do this project. Yeah. Yeah, the data set that was used for this project was basically got from Kaggle data. This was actually a competition. This was based actually on a competition, which is the poker rule induction competition. The data set contained 25,010 training rows, with each row which is identified like the each row is identified using like it gives the information on what are the suits and the cards in the below way. It is something like the um, the heart is represented as 1, spade is represented as 2, diamond as 3, and club as 4. And also the card numbers being given as 1 to 13, where ace is taken as 1 and queen king is taken as 12 and 13. Um, and at the end of the row we have the category or the class, the label which is from 0 to 9, which indicates like the 0 indicates there is nothing, the cards which are given has no hands, um, poker hands, and 1 says it there is a pair of hands, 2 says it has 2 pair of hands, and etc. So this goes till 9, which is royal flush. So we have 10 classes and basically 10 numbers which represents the five numbers which represents the suit numbers, and the other 5 represents the ranks of the cards. And yeah, basically we have 10 inputs and 1 output, which is a label, which is from 0 to 9. And in addition to this, we also have the data set for testing data set, which is having 1 million rows, um, and it is available at Kaggle, and it is open for submission, and also it doesn't have the hand information. So the aim of the project is to get the information on those 1 million rows, the hand information on 1 million rows, and to submit to Kaggle competition and check our scores. For the purpose of this project, we are using the three algorithms: decision tree without input features, decision tree with input features, and deep learning neural networks. In the first algorithm, which is decision trees without input features, we use the package in Python called the sklearn package for implementing the decision tree, and we basically took the training data and split it into training, validation, and test data. The training and the validation data were used to find the decision tree height. What is the decision tree height, which gives us lesser validation data, was found out, and the following graph helped us for doing that. This is the second approach, which is a efficient approach where we improve the previously used algorithm by um, by using feature extraction. We did a feature extraction on the input. In the first step of the feature extraction, we basically sorted the given input array. Basically, we did this because given a permutation of the same input, the model should be able to predict it as the same hand. So we did sorting at the first step, and at the second step, what we did was given given the example, say the example which is given in the slide, um, we created a input feature array which is of length 9, where the first four numbers represents the difference between each of the suits in the sorted order. So given these suits, that is heart, club, diamond, and spades, whichever is shown here, we'll get the output as 0 2 0 1. 0 because the difference between, because there are two hearts and the difference between the two hearts will be 0, so that's why there are two zeros. Two zeros represents there are two kinds of similar suits, and the fifth number represents the high card in the rank wise, which will be helpful for determining if it is a royal flush. And the last four numbers represents the difference between each of the card numbers, which is similar to the suit numbers. Yeah. The input feature which was extracted is given as the input for the decision tree, and this is what the results look like. We can observe that at the very lesser number of lesser height of the tree, we got the validation and training errors to almost 0, uh, which is very efficient when compared to the previous algorithms, wherein we got the height which is approximately more than 9 or 10. The next approach we used is using deep learning neural networks. We basically use the Keras Python library, which is built on the Theano library, to implement the deep learning neural network. The similar approach for feature extraction was done, and the feature extracted input was given as the input for the network. We have the configuration of the network is as shown in the slide. It has these many three hidden layers, one input and one output layer with 9 neurons and 10 neurons, and the batch size was taken as 100 with epochs 200. The results of deep learning neural network was fair enough, wherein we got the validation score up to 99.29% for 50 epochs, and the variation of training score was is as shown in the slide. In addition to the graphs that we plotted in the previous slides, we also ran our efficient algorithm, which is the decision tree algorithm, on the 1 million test data which was available at Kaggle, and we got a good score of 0.99932, which is equivalent to a rank of 77 in the leaderboard. Um, and yeah, and that was our project about, and we look forward to uh, publish this in any conferences or journals in the future. Thank you.